Dear friends, dear colleague, welcome back to the Mangano Digital Academy. Welcome to the Essential of Digital Dentistry. In the previous lecture we have talked in detail about implant planning, and in this lecture we will focus our attention on a very selected topic, the congruence between the mesh captured with the intraoral scanner and the library of the implant inside the computer-assisted design software. So we focus our attention on the prosthetic phases, the first prosthetic phases that are key for the final results in terms of success of our prosthetic restoration, in terms of adaptation, fit precision, in terms of clinical precision, in terms of success. So let's go through this, and we will talk about a study that I have performed together with my group in 2020, together the group at the Second of First Aid Medical University of Moscow with Professor Oleg Makin and our co-worker, and published it together with Dr. Henriette Lerner in the Journal of Clinical Medicine. As I told you before and in all our lectures of this project, of the project of Essential in Digital Dentistry, we have 4 phases in the digital dentistry. We have a first phase that is a data acquisition phase by means of scanners. In the case we are talking about the intraoral scanner, but also the desktop scanner as well, because the principles are the same. Then we have data elaboration inside the software, and we have different steps inside the software, and it's important to consider all these steps because every single step is key for obtaining the final results. Then we have the production, the making of the restoration, in this case the individual hybrid abutment, and the restoration, provisional or final restoration, and then the clinical application. So this is the scheme, and the scheme is always the same. The pathway for the success is always the same. We need to consider all the different steps and in detail. And here we are talking about implant supported restoration. So from the single implant to the multiple implant with the bridge and to the full arch. There are principles that are valid for all this kind of restoration, for all implant supported restoration, and we need to evaluate carefully and consider carefully all these principles. And the question is in this lecture, is there any congruence between the scan body meshes and the library file, the corresponding library file? It's really very important, and it's unfortunate that the literature didn't consider and didn't investigate enough this topic, because it's really key for the final success, for the final precision of our restoration. So let's go to this video that helps us to understand everything. We have this intraoral scan, a single implant, lateral incisor. This is the scan with and without the implant scan body. The scan body mesh is there. The scanner software has reconstructed the surface reconstruction of the object. We have this mesh, the mesh of the scan body. Then the dental technician receives this scan inside a computer-assisted design software, in this case Exocad, and needs to replace the mesh of the scan body with the library files that are all coupled inside the library in the perfect position. And this transfer or disposition of the implants is made through this device, the scan body. So it's very important to have a perfect alignment of the scan body mesh with the scan body library file, because all the other components in the library, like the different T-bases with the different angulation, different features, they are all linked in the correct position through this scan body that is available in the library. So it's very important to perform this superimposition at best. And this superimposition can be performed at best only in the case there's a high congruence between the library file and the mesh of the implant scan body. This step is critical, but the dentists usually don't know nothing about this step, because in real, this step is performed by the dental technician. The dental technician should perform this step at best, identify at first the landmark on the scan body mesh, and then launching the best fit algorithm inside the software, and then checking if there is a congruence or the congruence is missing, because we can have differences, dimensional differences between the scan body mesh, unfortunately, and the library, and this creates problem. So we have performed this study in order to verify the dimensional congruence between the scan body meshes and the corresponding library file using 5 different intraoral scanners and also 1 desktop scanner. So basically the method of the study were as follows. A gypsum cast of a fully edentulous maxilla with 6 implant analogs and scan body screwed on was scanned with 5 different intraoral scanners. In this case, the Prime Scan from Dentsply Sirona, the CS3700 from Kerstin Dental, the Medit scanner, the iTero Elements 5D from Align Technology, and the Emerald S from Planmeca. The single operator, in this case was me, captured 10 scans with each of these intraoral scanners. We also used a desktop scanner capturing 3 scans. And then the resulting meshes were imported inside a reverse engineering software for 3D analysis. And the 3D analysis consisted on the superimposition of the scanbody library file, a single library file, the same library file for all the implants, onto each scanbody meshes in order to verify quantitatively if there were deviations and qualitatively what kind of deviation, what kind of pattern this deviation said. Because it's very important, it's key for the final results. And we see that we found differences between the different intraoral scanner, different level of congruence. And this is the topic of the study, and we watched this study in detail today. So the model was this one prepared by my friend, the dental technician Uli Oshil. There's an edentulous maxilla with 6 scan bodies screwed on. These scan bodies are 13mm scan body from the Megagen company used with the NRG implant. This is the title of the study, Congruence between meshes and library file of implant scan bodies, an in vitro study comparing 5 intraoral scanners, published in 2020 in the Journal of Clinical Medicine. So we used this reference scanner to capture some scan also with a desktop scanner, but we also used 5 different intraoral scanners, and we captured 10 scans per each one of these scanners, as I told you, in order to have a set of 50 meshes coming from the intraoral scanner and 3 meshes coming from the desktop scanner. The intraoral scanners were very different in terms of technology for the acquisition of the image, for features. We have used standard tessellation language files exported from each one of these scanners in order to perform the superimpositions, of course. And it's interesting because different acquisition technologies means also different algorithm for the reconstruction of the surface of the scanned object, in this case the model. It means different interpolation methods, and everything changed because we can have really different results from different scanners, and nobody really investigated this topic in depth, so it's really something important. So 10 scans with each intraoral scanner, same experienced operator, same strategy under the same condition, temperature and humidity. In all scans, using a reverse engineering software, we have replaced the scan body library file to the scan body library mesh. We have superimposed it. That is the step before replacement. And before to replace it, we have evaluated the quantitative and qualitative congruence among the two parts, between the two parts, the mesh and the library. So the master model, as I told you, 10 meshes per each one of the intraoral scanner, 3 meshes for the desktop scanner, because we also wanted to investigate a little bit the behavior of the desktop scanner, which may be different from the one of intraoral scanner, because of course there are different acquisition strategies, obviously. And then we have taken this library file and we have superimposed this library file by means of individual landmark at the beginning, and then launching the powerful algorithm for the automatic superimposition. We have superimposed the library on each mesh, so we are talking about hundreds of superimposition, of course, globally, and we watch the results. And these are the results. The script is statistics. It's a long table, I don't want to bother you. There are the different 6 scan bodies and the 5 scanners, intraoral scanners. More or less it was so. The quantitative evaluation reported that there are 2 scanners, PrimeScan and CS3700, that performed better than the other scanner in terms of deviation, in terms of congruence, because they had a congruence that was comprised between 20 and 30 microns, so the deviation was minimal quantitatively between the scan body meshes and the library file. Instead, the other scanner had higher deviation. And higher deviation means a lack of congruence in this case, and congruence is key. Let's go to see a comparison between the different scanners. We see that the first two scanners, PrimeScan and CS3700, they don't have a statistically difference among each other, because if you compare them, the result was similar. But compared to the other scanner, then a statistically significant difference in the congruence emerges. So it's very important to choose a proper scanner when scanning implants, because there are features that probably related to the acquisition technology that can help this scanner in the reconstruction. The reconstruction is more congruent to the library file. And also here the best results. This is very, nice to see these results, because we see that the error is really little for all the scanner. And we also surprisingly see that the deviation with PrimeScan with the CS3700 is even less than deviation with the desktop scanner for the best results. So it means that really we have powerful tools when we use intraoral scanner. But we see this color map, as you can see. The color map more or less must be read accordingly. If I have a blue color, then I have a deviation in defect. If I have a yellow or red color, then the deviation is on the other direction. I give you an example. In this case, the mesh is huge when compared to the library. It's a little bit bigger. So the library is included inside the mesh for the CS3700 and clearly for the desktop scanner. It means that these scanners have a tendency to reconstruct a scan body that is a little bit bigger than the library file. Instead, PrimeScan and iTero Elements and Emerald S have a different pattern. They usually reconstruct a little bit in defect. So we have the library that is a little bit bigger than the mesh itself. With maybe there's a sort of interpolation, but we will see that in more detail. The point is that, of course, there are differences also among the different scan bodies. That means that we have a problem with the scan body because maybe some of the scan bodies are bigger than the library, and tolerances are something that we can find in the literature. But in a recent study that I have published with Dr. Henriette Lerner and my group, Professor Oleg Makin, we have evaluated the quality of this scan body in particular, and we found very little tolerances. So probably it's not related to the tolerances of the scan body. This may be related to the position of the scan body and the way we scan them. Because as we see from this table, we see that the lack of congruence is particularly found in the anterior area of the model. Why? We don't know why, but probably because we insist too much, we create noise. I don't know, but it's something that must be investigated by the literature, considering and pointing out that the fact that the tolerance for the fabrication of this scan body is very little. In the study published in the International Journal of Prosthodontics, online, I had a print now in PubMed, we have seen that we have very little manufacturing tolerance exactly for this kind of scan bodies from the Megagen company. So probably this error must be related to the position of the scan body, to the way we scan them. Here another table, as we can see, mean absolute deviation estimate for each scan body for each scanner. And once again, the scan bodies in the anterior area, scan body 3 and scan body 4, have a higher error for all the scanner. So probably it's related to the strategy. It's something that we need to consider. Maybe we need to revise our strategy, but obviously there are statistically significant differences between the different scan bodies inside the different groups of scanner. We can see here, while we don't have statistically significant differences among the models, because we have captured 10 models per each scanner, and among the model within each group we don't have any statistically significant difference. So the operator is the same, the condition are the same, the strategy is the same. Among the model we don't see any statistically significant difference. Among the scan body we see a statistically significant difference. This must be related, this may be related to the scanner strategy in this case. And if we watch this table, the hierarchical big clustering result with the scanners and the scan body grouped based on the average absolute deviation, we see that we have likely to have the best results with scanbody 2 and scanbody 3 with PrimeScan and CS3700, while the scanbody 3 and scanbody 4 with Emerald and iTero, they give the worst results. So it means that probably there's a scanbody factor. There is a scanbody factor for the position of the scanbody, not related to the tolerance of the manufacturing of the scanbody, the position of the scanbody related to the strategy we are using here. There's also a scanner factor, so some scanners are better than the other in terms of congruence. And here, this other hierarchical back clustering seems to confirm it, that we have very good results in terms of stability with some scanner. In this case, the stability is very high, the reproduction of the results is very high with iTero and Medit. If we watch qualitatively, as I told you, we found one very interesting thing in the study is that CS3700 and the desktop scanner, they have a tendency to create a mesh, to reconstruct a mesh for the scanbody that is a little bit bigger than the scanbody library file. Instead, all the other scanners, they do the opposite. Basically, the mesh is included inside the library file after superimposition. What does it mean? It means that probably we should adopt different strategies and technology when we adopt different scanners. Because, for example, in the case of a scanner like CS3700, then we could avoid to insist too much in capturing all the tiles of the scanbody, because we can create noise and we can create difficulties in the software for the interpolation. Better to capture fast all the structure and then to save it. We don't need to create noise. Instead, with iTero or Emerald S, we need to insist a little bit more in order to create a little bit more noise, because the phenomenon of post-processing after interpolation remove outliers, even too much. So we need to balance a little bit this phenomenon. What comes from this study is that qualitatively, more or less, in all cases, we have a pattern, and the pattern is that the CS3700 and the desktop scanner have a tendency to reconstruct a mesh that is bigger than the library file. Instead, all the other scanners reconstruct a mesh that is a little bit more included inside the library file when superimposed. So the conclusion of the study. Our study aimed to compare the reliability of 5 different intraoral scanners: PrimeScan, CS3700, Mediscan, iTero Elements 5D and Emerald S, in the capture of implant scanbodies, and verify the dimensional accuracy and congruence, in this case, the congruence between the meshes and of the scanbodies and the corresponding library file. In the quantitative evaluation, we found different level of congruence between the scanbody meshes captured with the different intraoral scanner and the corresponding library file. In particular, PrimeScan and CS3700 show the highest congruence between the meshes of the scanbodies and the corresponding library file, with the lowest mean absolute deviation, in this case 25 and 27 micron respectively, per each scanbody, so lower than 30 micron. So the difference between these two scanners and all the other group of scanners was statistically significant. They look more congruent, they look more accurate in this specific indication. Also, significant difference was found among the different scanbodies, and considering that in previous studies we have verified the manufacturing tolerances of this scanbody, we found very little manufacturing tolerances, probably this phenomenon may be related to the strategy used in this study. So we need to investigate in depth the strategies used to capture the full arch scan in order to reduce the error and in order to adapt the strategies exactly for the specific scanner we are using. Finally, we found no differences between the model scanner with the same EOS. So the quantitative evaluation reflected this concept, and the qualitative evaluation revealed also different direction and pattern for the 5 intraoral scanners, with a peculiar direction and pattern for reconstruction for the casting one more similar to the desktop scanner. I think all this information are very important, and of course there's a need of more literature, there's a need of more research, there's a need of more studies, but one of the very important recipe for success when working with implant support restoration, particularly in the full arch, because of course if we are making one implant, one crown over an implant is not so important, but the more implants you add, the more difficult it is, so the more precision is needed. When we capture the scan body, we need to capture the whole scan body during the optical implantation, but we need to avoid to insist too much in order to reduce the noise. We need to consider the scanner we're using. For example, with the CS3700, the scanner that I'm using, I need to avoid insist too much because I know that the algorithm used by this scanner reduce a little or cancel or post-process little the outliers. So I have usually a mesh that is quite huge, quite big, and this mesh is bigger than the library file. So in order to avoid a noise effect, I need to scan faster and to avoid to insist too much on the tiles. For example, with iTero, for example, with Emerald S is different. I can insist a little bit more because I have the problem, the opposite problem. I have a reconstruction that usually is little when compared to the library file. So different scanner, different strategies that we need to adopt because they have different algorithms, and the literature need to investigate this topic very well. Anyway, one information that is very important for the dental technician need to check carefully the congruence between the scan body meshes and the library files at the very early phases of the computer-assisted design. Inside the exoskeleton, and for each scan body, deviations that are less than 30 micron are acceptable clinically. Deviations that are more than 30 micron should not be considered acceptable, particularly in the full arch case. If I have a congruence that is less than 30 micron, it's okay. If I have a congruence, a mean congruence, a mean deviation that is more than 30, 40, 50, 60, then I don't need to go on with planning because I will have trouble clinically in terms of precision, particularly in the full arch. So the dental technician should watch every single replacement, should check every single replacement with the colorimetric map, and should watch quantitatively if this deviation is per each scan body more than 30 micron. If it is, better not to proceed because the position of the implant after the application of the algorithm of the computer-assisted design software will be likely to be mistaken with a mistake in the position, and this will not reflect the actual position of the implant in mouth. So thank you very much for your kind attention. These are very difficult concepts, but basics for modeling proper, precise implant supported restoration, particularly in the complex cases, particularly in the full arch. The congruence is very important. We are not talking about only the accuracy of an intraoral scanner, we are talking about the congruence. Thank you very much for your kind attention.